What's up, guys? Welcome back to the channel. Today I'm going to be doing something a little bit different. Today I'm going to be talking about recursion, what it is, and I'm going to work through a couple of demonstration problems in JavaScript to kind of better show what it is that recursion is, why it's helpful, and things of that matter. So right to the point then, what is recursion? So recursion is a concept in computer science. Right here, the definition from Wikipedia says that in computer science, recursion is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. Such problems can generally be solved by iteration, but this needs to identify and index the smaller instances at programming time. So basically, like, things that are recursive functions can generally be solved with loops as well. But utilizing recursion is a little bit fancier, and sometimes it's preferred for just readability, basically. Recursive functions can typically be shorter than writing loops, and then there's things like when you're iterating over really complex like objects and trees and things like that, which I am definitely not good enough at recursion to do at this point. But those things would be insanely difficult to do with loops, and recursion makes them much easier because you don't know how many levels deep those complex data structures go, and recursive functions will definitely be your friend in cases like that. Typically, the most common example that you'll see for recursive functions, which is kind of unfortunate because like everybody uses the same example to like every resource that you go to, and so it becomes really hard to find out ways that recursion can be useful in any other method besides just like finding out what the factorial of a number is, which nobody really needs to do like ever. So I just pulled up a couple samples here on Edibit. Edibit is kind of like websites like Code Wars or what's the other one? Leak Code, things like that, HackerRank, where they have practice toy problems where you can get better at solving, practicing different patterns in various programming languages and things like that. It's also great for interview prep. So the first one we'll look at here is recursion sum. So we're going to write a function that finds the sum of the first n natural numbers. So make your function recursive. So they have some examples here. So sum 5 equals 15. So this is basically sum 5 is equal to 1 plus 2 plus 3 plus 4 plus 5 equals 15. So let's see. So I'm actually not going to solve these over here at first because I'm going to do this over here in Replit. Replit is it's a cool little website that basically lets you run JavaScript in the browser, so it's easier than like having to do it over here, because over here you can't use like console.log and things like that. So if I do it over here, then I can see my log statements. So copy the function over, and then let's see, back to the instructions here. So okay, so when you write a recursive function, the first thing that we need is a base case, and then we're going to need the recursive case. So first we're going to find our base case. So the base case is basically when the recursive function is going to stop. Because if you don't have a base case and you try to run a recursive function, basically it's going to run forever until you exceed the maximum stack, and then your application is just going to stop basically whenever that happens. Basically it's saying like the function executed so many times that the browser ran out of memory and it can no longer function basically, and it obviously knows that you did not mean to run the same function 16,000 times, and so it just stops itself for you. Let's see. So our base case here is going to be if n is equal to 0, return 0. So we want to return 0 if n is equal to 0, because if it is, if we call sum 0, there's no numbers to add together, so it's already 0. So our recursive case is going to be, well, actually, I don't think I need that, so we'll do return, so n plus sum n minus 1. I can't remember. Let me see. Actually, let me come over here and get their test cases here. Well, I can just use these ones. So we'll call sum 5, sum 1, and sum 12. And then we'll try this. All right, and it looks like that's correct. So this is basically saying n, the current number. Oh, geez, here we go. Oops, I hope I didn't just ruin that. Okay, we're still good. Let's get dark mode back though. Okay, so if n is equal to 0, return 0. Otherwise, return n, which is the current number, plus sum n minus 1. So this is going to essentially recall this every time, and it's going to add basically n plus n minus 1 all the way down until it's equal to 0, and then return. So the last call of this function will return 0. All the other calls will basically be adding to this last number, and when it gets back to the original function, it's going to return whatever n plus all those other numbers was. In the case of 5, it was 15, and then 1, and then 78. So, and actually, if we wanted to, we could actually make this even simpler. So we could turn this into a ternary operator, which is basically like a one-line conditional statement. If you're not familiar with ternary operators, they're pretty cool, but they do not fully replace if statements. So to do that, we would basically say n equal to 0, question mark 0, or this. And then we can delete all of this. And if we run it again, we get the exact same thing. So if we copy this over to here, check it. Sometimes Edibit takes a little while. Their website is awesome, but can be a little slow sometimes. So as you see here, we passed all the test cases for this problem. Awesome. Now we can go on to the next one. All right, so let's go on to the next problem here. I went ahead and I cut the video for a minute, and I went ahead and set up the next problem here just for time constraint reasons. So this one is going to convert minutes into seconds. So we're going to write a function that takes an integer, which will be our minutes, and converts it into seconds. So let's see. So we're going to need our, going to need our base case and our recursive case. So our base case here is going to be if minutes, let's see, this one is basically the same kind of recursive case. So if minutes is equal to 0, basically there would be no seconds. So if it's equal to 0, we're going to return 0 just like before. Otherwise, we're going to return, so for this problem, we need to know how many seconds are in a minute, which is 60 seconds. So it's basically going to be 60 times, or it should be 60 times, convert minutes. Actually, this is going to be wrong. 60 times convert minutes Nope. -1, because this is already equal to 1, so this should actually be a plus and not a multiplication. So let's try this. Yep, so convert 5 right here is equal to 300, convert 3 is 180 seconds, and convert 2 is 120. And if we wanted to, there's nothing wrong with this solution, but again, if we wanted to, we could, you know, put this into a ternary operator and, you know, just kind of like simplify it into one line here, and then get rid of this. So same thing, we'll copy this over to here, we'll check it, and we'll wait to run the tests here. And it passed all of the tests. Awesome. So this is another recursive function, and this one will convert your minutes into seconds. Now let's take a look at another one that's a little bit harder. I haven't actually done a problem like this before, so we'll see how this goes. Okay, so this is going to be the third and final problem that I'm going to do here for this video. So this one is a little more complicated. Basically, we're going to recurse a string to determine whether or not it's a palindrome, or a palindrome, however you want to say it. If you don't know what a palindrome is, it's basically a series of letters. It doesn't have to be a word. It can be an empty string, a single letter, or a series of characters, as long as if you reverse it, basically it equals the exact same thing. So it's the exact same characters in order, whether you read it from left to right or right to left. So for this one, like I said, this one's a little harder, so this one may take me a minute. I think for our base case, we're going to say if string is equal to an empty string, we're going to return true. And let me add one more test in here. Put it right here. We'll test the empty string. So that's our base case, because if the string is equal to empty right here, it's automatically true. So return, let's see. Yeah, this one's a little harder. Like I said, I'm by no means like an expert in any of this. I'm just trying to share what I do know, and you know, maybe it helps me too along the way, because recursion is not my strong suit. So I know that basically we're going to be comparing the first and last characters. So why don't we try this? I think I'm going to try and do this like right away as a ternary operator. So we're going to say string 0 equal to string -1. Or actually, let me just do it like this. Length. This should basically get us like the last character in the string. So if I do like console.log str0, that'll get us like the first character. And if I do, let me just copy this. So if I do it like this, should give me the last one. Yep, so that'll work. Okay, cool. So now we have a way to get the first and last characters of the string. So we want to know, is the first character of the string equal to the last character of the string? If this is true, we want to call this again, but and I have to look up this method here. So we should be using slice for this, I believe. Let's see, slice method extracts a section of a string, returns it as a new string without modifying the original string. Yeah, so well, just let me use -1. Extracts the third character to the last character. Okay, so I think this will work. So we're gonna do str.slice, and what did that say? Okay, yeah, so we want the second character through the second to last character, because we don't want to include the last character in that. So if these are equal, if those are equal, call it again with everything but the last two, everything but the first letter and the last letter. So basically every iteration we're going to be knocking the first and last letters off the string until we get down to 1. So let's see, or return false. So let's see if this works. Okay, that does not work. Oh, sorry, I'm missing. Oh, that's what I took that off. I didn't think it needed to be there. My bad. Okay, now what's wrong? Oh, I don't need the return here. It's like double return. Okay, there we go. So might have done this backwards. Let's see. So A, B, and C. That should be true. This last one should be false. Yeah, let me take these out of here. Sorry about that. I'm gonna console.log this and see what comes in here. Oh, I'm console.logging the wrong thing. I actually need to see what this says. Maybe I just did this wrong. Let me see. Sorry, now I'm like troubleshooting over here. Let me try this again here. Okay, I think that's what I did wrong. I think that that was supposed to be -1 instead of -2. Yeah, so all right, so this is what we're looking for basically, because if you see here, so this starts and ends with A on the first iteration, and then when we come back through, we call it again, we hack off basically the first letter and the last letter. So then we're calling it as BCB, and the first two are still equal, so that will return true. Call it again, hack them off again. Now it's equal to C, which if you reverse it, it is again going to be true, because as we see over here on this example test case that they give us, B by itself is still the same forward and backwards, so it is indeed a palindrome. And then call it again, basically cutting B off of it, and then we're down here to our base case, which is an empty string, which will return true, and then this function overall will return true. And it's the same case for all of these except for this last one here, because A and D are not equal when spelled, are not the same spelled forward as they are backwards, so that one will return false. So now that we have this, we'll bring this back over here, paste it in, and we'll test it. And all of our conditions pass. So awesome. We now have a recursive function to test whether or not a string is a palindrome. So awesome. I had a lot of fun recording this video, working through these problems. Hopefully this is helpful to some people that are currently learning recursion. I'm definitely still learning recursion myself. It's a pretty hard topic, and some problems are definitely harder than others, especially ones where like you start working with like arrays and things like that. They get a little more complicated, like this one that I just did here, the palindrome problem, is a lot harder than solving the ones where you're just trying to like sum up some numbers and things like that. If you guys like this video, let me know in the comments below, and let me know some other things that maybe you'd like to see some sample problems over, some formula like tutorials or something like that. Maybe I'll see if I can do something like that for you guys. But yeah, like I said, hopefully this is valuable to you guys. If you like the video, make sure to hit like and subscribe and stick around for future content. Until next time, guys.